The spring of 1994, a tranquil and remote corner somewhere in the north of the Netherlands, Grijpskerk. This is the unlikely setting soon to become an important part of the Dutch energy supply market. At Stork Engineers and Contractors in Amsterdam, more than 90 professionals are making ambitious plans for this one village in Groningen. A company is commissioned to erect 10,000 meters of fencing around a nearby plot. Elsewhere in Europe, welders begin work on an enormous task. Discussions are being held all over Europe, all concerning that secluded spot in northern Netherlands. The local bicycle shop receives an order for 140 mountain bikes. These people expect to be here for up to 18 months, and they travel around the area to look for accommodation. A house, a hotel.
2 extra days in the same room.
What's all the fuss about? The construction of one of the world's largest underground gas storage plants. A mega project worth over $500 million to be executed by Stork Engineers and Contractors. The demand for natural gas varies day to day. In wintertime, there is a higher need for gas, and in extremely cold periods, there are often peaks in demand. Due to the annually decreasing pressure in the surrounding gas fields, the ability to meet such peak demands is uncertain from 1997 onwards. To compensate for this, a peak shaver could supply the gas grid with the extra amount of gas required. This is achieved by creating a gas buffer by injecting gas into a depleted existing underground reservoir. A suitable gas field has been discovered 3,200 meters underground Grijpskerk. Natural gas can be pumped in here from other gas fields during the summer, up to a pressure of 350 bar. In the following winter, this field can then supply large amounts of gas during peak demand periods. This so-called peak shaving supply capability must, however, be available whenever necessary. The general concept of such a facility is as follows. 10 hectares have been reserved for gas input and output to and from the underground gas field. The gas is transported from the wells to coolers, where the hot gas is cooled and liquids are separated. The gas then continues on to the dehydration units, where it is dried and conditioned. The liquids are separated into water and condensate and stored in tanks. The saturated dehydration units are then regenerated and ready for further dehydration duty. Mercury and common salt are also extracted from the gas. Dust particles are then filtered out to meet the sales gas specification. Incoming and outgoing sales gas from and to the gas distribution grid are accurately measured. Similar gas plants have been built in Alkmaar and Langelo to supply gas to other gas grids. All this to guarantee domestic gas demand for the next 10 years.
Ja?
Stork Engineers and Contractors were commissioned in 1994 by the NAM, Dutch Oil and Gas Production Company, to construct a peak shaver with underground gas storage close to the Groningen village of Grijpskerk. It was awarded as an EPCM contract with full scope of responsibility for the engineering, procurement, construction management, and commissioning. The peak shaver had to be operational by the end of 1996. The basic design was done in 4 months. 3D computer-aided plant design techniques were used to accelerate design and to aid construction and operations staff. The mission was construction-driven engineering. There was plenty of work to be done, and quickly. Construction activities must start by January 1995. Up to 1,000 people are engaged at times on the site, working for the 13 main contractors and all managed by Stork. A watertight system of work permits ensures safety at work. Applications for the necessary permits to work all take place centrally and are controlled and administered by Stork. Hundreds of drawings are issued daily, forming the basis for work preparation and execution. A mega project. It involves 300,000 cubic meters of sand, 6,400 piles, 23,000 cubic meters of concrete, 1,200 kilometers of cable, 4,000 tons of steel, and 8,000 tons of pipelines. Their international know-how and experience enable Stork staff to buy worldwide all materials and equipment efficiently and under attractive commercial conditions.
FB 360. Okay.
To minimize site activities and required labor forces, various components are modularized elsewhere. Delivery of pre-assembled equipment has been scheduled to arrive on site just in time, with prefabricated components being delivered to Grijpskerk on call. Coordination of the transport and logistic planning is also Stork's responsibility, whether by road or by ship. Such as here in Italy, where absorbers 12 meters long and weighing 320 tons are made. They are first transported over the inland waterways by barge to a nearby seaport, and then by sea freighter to Amsterdam, where they're again transferred onto barges. An old unloading quay has been specially adapted, located 6 kilometers away from the site, where the adsorbers are offloaded onto trucks for the final stretch. September 1995. The last cooler module has just been installed. And 40% of the pipe bridges are erected. Welding work is also underway on the storage tanks. Things are dead on schedule. Planning material status, safety and construction progress are discussed regularly with client and contractors. Video conferencing allows for efficient and direct consultation between the site and Stork headquarters, thus reducing traveling time to a minimum. On site, the computer-aided 3D model of the plant is used as an aid to construction staff involved with work organization and preparation of work permits. And sometimes there's time to relax. Autumn 1995. A setback. Rain and storm. Conditions are tough. The flare modules are erected under adverse weather conditions. At 80 meters in the air, that's tricky. For the entire project, up to 3 million man-hours have been forecast. The site health and safety rules are strict. A pass and entrance control system ensures optimum security. Everyone follows safety courses. And there are regular safety drills.
Van Wijk! Van Wijk! Sanders!
Public access roads are cleaned weekly, daily if necessary, taking care of the surroundings. Winter, late 1995, and 10 Celsius below zero. 12 months until D-Day. The frost has bitten deep into the ground and work is 4 weeks behind schedule. Tents are erected so that essential work can continue. March 1996. The backlog is now 6 weeks. Contingency plans are put into effect. The schedule is adapted to make up for lost time. Extra manpower is deployed and a double shift organized. 8.6% progress per month has now to be achieved. The compressor will ensure that the gas is injected to 3,200 meters depth in the reservoir at pressure up to 350 bar. It's the first of its size and kind in the world, installed with an enormous 38 megawatt variable speed motor. The pipes for gas injection, nearly 7 centimeters thick and able to withstand pressures of 390 bar. Weight, 1,000 kilo per meter. A plethora of sophisticated monitoring and control equipment is prepared for testing. The plant can be controlled from a remote control center at Hogesand, 40 kilometers away. An extensive signal transfer and monitoring system has been installed for this purpose. October 1996. Back on schedule. 96% of construction work is finished. Just a few last jobs. And an intensive 3-month period lays ahead for testing and commissioning.
Ga die, hoe heet dat, die FT nog maar een beetje omhoog halen.
Is oké. Of zitten we misschien erg laag in de temperatuur?
Meanwhile, the site cleanup begins. The plant and surrounding areas are tidied up with great care. December 19th, 1996. Stork commissioning staff, together with NAM operators, carry out final testing and tuning. A complex project has been successfully completed. Within the time, and within the budget. In rapid succession, the injection facilities are completed too. 2 months ahead of schedule. 2 winners here, Stork as well as NAM. Mind has triumphed over matter.